Hello everyone, this is the continuation of the study guide, starting with problem 11 here. We need to solve the equation for x. So what I want to do right now is I want to pull the 2 root x plus 4 to the other side. And that means that we're going to end up crossing these two off, and we're going to have x plus 1 is equal to 2 root x plus 4. And we want to solve for x. So I'm looking to get to the x underneath the root right now. And so I'm going to raise both sides to the power of 2. And what ends up happening is I expand and multiply on the left. X plus 1 times x plus 1 is x squared plus 2x plus 1. On the right, 2 times 2 is 4, and then the square root of something to the power of 2 cancels the root and the power of 2. And so now we have to distribute in the 4. And that gives us a 4x plus 16. And from here, we have x squared plus 2, sorry about that. Let's go ahead and subtract 4x to both sides. Gives us a minus 2x. Subtract 16 to both sides. That gives us a minus 15. And we've got a factor. And we have a 3 and a 5, and a minus 5 and a plus 3, which gives us x is equal to 5 and negative 3. There's a problem with one of these, so let's plug them in and see which one of these gives us a problem. Alright, so I plugged in the 5 to start, and here we have a 5 plus 1, which is 6, and over here we have 2 times the square root of 5 plus 4, which is 9, which gives us a 3. 2 times 3 is 6, so we have 6 minus 6, which is 0. That checks out. Let's see if the negative 3 checks out in the same way. Okay, so I plugged in a negative 3, and I'm ending up here with a negative 4 is equal to 0, but that's not true. That's not true. That's no bueno. Negative 3 is not in our solution. It's called extraneous, and we can only use the 5 in our solution. Let's move on to the last set of problems here. I'm going to make the assumption that you guys are good with that one. So I'm going to do B, C, D, and E. I think these ones are the most problematic, so let's focus on those. Let's start off with B. I want to figure out where 2x squared minus 7x plus 3 is greater than or equal to 0. So the first thing I need to do is actually figure out where x is equal to 0. That's the first thing I want to figure out. And so let's see, we have a 2x times x is 2x squared. And then a 1 times 3 is 3, and the outer 2 gives me 6x, and the inner 2 gives me 1x. And that'll give me a negative 7x if both of these are negative. So that means I have two values here on my number line. One is at positive 1/2, and the other is at positive 3. Those are the two values. And those two values give me equal to 0, and I want to include those two values here. I want to plug in. I can include 1/2 and 3. Those are a part of my solution because they give me equal to 0. Now what I want to do is I want to figure out where I'm in the positive and where I'm in the negative. So let's go ahead and plug in a value. Let's plug in our favorite value, 0. So we'll plug in to the left of 1/2 over here. And I'll plug in 0 into this spot and this spot here. And some of us can see what it is already, right? Because everything wipes off except for the 3, the plus 3. These guys wipe off, and we're just left with a plus 3. So that means that over here, anything I plug in prior to 1/2 is going to result in a positive. And anything in between 1/2 and 3 is a negative. Anything after 3 is a positive. So, going back to our problem for B, we want to figure out what are the x values that are going to result in greater than 0. We're talking about positive x values. So anything that we plug in from negative infinity to 1/2 will result in a positive x value. And then anything that we plug in from 3 to positive infinity will result in a positive value here. Okay. And let's move on to the next problem. Part C is where we're going. Okay, so it looks like part C, we have the same exact type of setup. It's just we're looking for where what x values are going to give us result in negative values. What x values can we plug in and give us negative values less than 0? So I'm going to just draw my number line here, and we know that we're not going to include these values this time, because when we plug them in we get equal to 0, which is not a part of our solution. So we know the sign chart already, and the sign chart says plus, negative, minus, and we're looking for less than. So we're looking for negative. Anything that we plug in between 1/2 and 3 is going to result in a negative value. So that's our solution from 1/2 to 3. Alrighty, let's move on to D. Part D says we want to figure out the x values that are going to result in positive values that are greater than 0. So let's figure out where we're actually equal to 0. So I got a factor, and then figure out my x values that actually cause 0. So if I factor this, looks like this is rounding out to be a perfect square trinomial. So we have two of the same exact binomials. And so that means that here we have a situation that gives us a negative 2 over 3 for the only point that would give us 0. So negative 2 over 3 is our testing point, and we can't include that value. That value here is not included because there's no or equal to. We have to figure out where we are greater than 0. And if I tested a value prior to negative 2 over 3, then that would result in a positive value. If I test a value after negative 2 over 3, that would result in a positive value. So we can plug in any value except for negative 2 over 3. Any value except for negative 2 over 3. So we're going from negative infinity all the way to negative 2 over 3, not including the negative 2 over 3. And then from negative 2 over 3 all the way to positive infinity. All right, let's think about one more here. This next one is part E. Just erase everything we have here. And now we got to think about, well, that's the same question. Why would I do that, huh? Let's add this here, less than. Well, is there any x value that's going to result in a value that is negative? Is there ever going to be a time when this is true? No. So if E had 0 is greater than 9x squared plus 12x plus 4, then this would be no solution. No solution. But let's say it said or equal to. Or equal to. Then that would mean that we would include the 2 over 3. But that's the only value that we would be able to include. And so therefore, we would only write that one value, the negative 2 over 3. That would be the only value that we could include in our solution. That would give us 0. Every other value will result in positive, but we're looking for negative or equal to 0. All right, let me know what your questions are. We will have a test coming up soon, so please don't be shy. I will see you all in class.